Alright, we're going to talk about finding the surface area of cylinders, cones, and spheres. All of these three-dimensional figures do have circles in them as faces, or the sphere is kind of like a three-dimensional circle. And so we're going to talk about circles real quick. The circle is the set of points in a plane that are fixed distance from a given point called the center of the circle. So in a circle there is a center point, and every point on that circle is the same exact distance from that point. Now the distance all the way across the circle through the center is called the diameter, and the radius is half the diameter. It's halfway across the circle. It goes from the center to a point on the circle, halfway across the circle from the center. The circumference of a circle is the distance around a circle. In most figures, we call the distance around a figure, around the outside of the figure, the perimeter. But in a circle, it's called circumference. We have two formulas for circumference, 2 pi r and pi times diameter. And hopefully it would make sense why both of those would give you the same thing, because the radius is half of the diameter. If I use radius, I have to double it. 2 times the radius would be the same thing as the diameter. So you can either just multiply pi times diameter or 2 times pi times radius, depending on whether you have the radius or diameter, but either one works. Area of a circle, the formula is pi r squared. So let's look at example 1, and let's find the circumference and area of the circle with a radius of 6.8 centimeters. So if I'm doing circumference, they just gave me the radius, so I'm going to use the formula that has r in it for radius. And it's 2 times pi times the radius. And so the radius is 6.8, plugging that in. Now I'm going to make sure on my calculator I have a pi button, and I'm going to use that instead of 3.14, just because 3.14 is rounded to the nearest hundredth. Pi, the number really is an irrational number that keeps going forever. And the calculator stores a lot more places, so I get a more accurate answer by using that. So I'm going to put in my calculator 2 times pi times 6.8, and I get 42.725, and so on. I'm rounding to the nearest hundredth, which means I keep 2 numbers after the decimal point. So I look at the third number, the first number I'm not keeping, to see if I round up, and that 5 is big enough to round up, so that means the last number I am keeping needs to increase by 1. So 42.73, and this was in centimeters. So there it is, 42.73 centimeters. Circumference is a one-dimensional measurement, so it's just regular units. So in this case, centimeters. Area, the formula is pi times radius squared, and the radius was 6.8. So I'm just typing that in the calculator. Pi times 6.8 squared equals 145.267. Again, I'm rounding to the nearest hundredth. I'm keeping 2 numbers after the decimal point. I look to that third number. It's big enough to round up, so the last number I'm keeping needs to increase by 1. And area is a 2-dimensional measurement. It is always units squared, so in this case, centimeters squared. Alright, here are the formulas for lateral surface area and total surface area of cylinders and cones. You should notice that the lateral surface area is repeated in the formula for total surface area. And pi r squared was our formula for area of a circle. If you think of a cylinder, you have 2 circles, and then you have the rectangle going around the side. So this formula right here is to find the area of that rectangle, and then you have 2 circles. So pi r squared gives you the area of 1 circle, and there's 2 of them, so we multiply that by 2 so that we're including the area of both circles. Also, something else that you might recognize as far as the area of the rectangle going around the side, think about peeling a label off of a can. It's actually just a rectangle. Well, when we do rectangles, we do length times width. Well, think about the length of that rectangle. It's got to go around this 1 time. Well, that's the circumference of the circle. You might recognize 2 pi r was the formula for circumference of a circle. And then the height of the cylinder would be like the width of the rectangle. So the circumference of the circle, 2 pi r, that's the length, and then the width is the height of the cylinder. And so that's where that formula comes from. You got 2 pi r times h, and that gives you length times width of that rectangle. On a cone, you have the one circle, and then you have what's actually a sector, which is part of a circle, if you were to unfold it, going around the top. The formula for the lateral surface area, just the area of that sector going around the side, is pi times radius times slant height. Now remember, this right here is the slant height. Radius is the radius of the circle down here. So you're just doing pi times radius times slant height. And then for total surface area, you'll notice that lateral surface area is repeated, and then you're adding pi r squared. A cylinder had 2 circles, 2 bases. Cone only has 1, so you just see pi r squared for the area of 1 circle. We add that to the lateral surface area to get total surface area. And then on a sphere, you might notice that there is no lateral surface area listed. Well, a sphere is a ball. Just think of a baseball or a basketball or a soccer ball, and they might not always be perfect examples, but a sphere is just think of a ball. It doesn't have separate faces. It doesn't have a base and sides. It doesn't have lateral faces and bases. It just has one smooth, solid surface, and so you can't distinguish between them. And so it's just a total surface area formula: 4 times pi r squared. All right, so there's our formulas. Let's see if we can use those formulas to find surface area of these different figures. So first we're looking at a cylinder. Cylinder is a 3-dimensional figure with 2 parallel congruent circular bases. Let's find the lateral surface area. So for lateral surface area, we got 2 pi r h. Okay, well, let's plug everything in. What's the radius? It's 3. And what's the height of the cylinder? It's 6. So there's everything. All we got to do is type it in the calculator. 2 pi times 3 times 6. And we're rounding to the nearest hundredth, so I'm keeping 2 numbers after the decimal point. I looked at that third number to see if I round up. 7's big enough to round up. Well, if I increase 9 by 1, it becomes 10. So the 1 has to carry over to the other column. So 113.10. This is in inches, so any kind of area, including lateral surface area, will be inches squared. Area is always units squared. Total surface area. You have the lateral surface area, plus you have 2 circles. So 2 times pi r squared will be added to it. Okay, so once again, this part we've already done, so I'm just repeating it. And then over here, the radius is 3. That's the only variable we have to plug in. So I'm just typing this in the calculator. 2 times pi times 3 times 6 plus 2 times pi times 3 squared. And I get 169.646 whatever. And if I'm rounding to the nearest hundredth, again, I'm keeping 2 numbers after the decimal point. That third number is bigger than 5. It's 5 or bigger. So I'm rounding up. So the last number I'm keeping needs to increase by 1. And again, this is a type of area, so the units will be squared, inches squared. All right, let's look at a cone. Cone is a 3-dimensional figure with 1 circular base and a curved lateral surface that connects the base to a point called the vertex. Alright, let's find the lateral surface area and total surface area. So for lateral surface area, it's pi r L. Remember, the r is radius. The radius here is 3. And L is slant height. Slant height here is 6. So we're just typing it in the calculator. Pi times 3 times 6 is 56.5487, depending on where you're rounding it to. We're going to round to the nearest hundredth, so keeping 2 numbers. That third number is an 8, so that's big enough to round up. So 56.55. And they didn't give me the units here, so I'm just going to write U for generic units. And it's still an area, so it's units squared. Total surface area, pi RL plus pi r squared. Remember, we're just adding in the area of that one circle, pi r squared. So we already did this part. Now I just got to plug the radius in here. Remember, radius is 3. I'm just typing that in the calculator now. Pi times 3 times 6 plus pi times 3 squared. So we type it all in the calculator. 3, keep in 2 places. 3 is not big enough to round up, so that just drops off. 84.82 units squared. Now, we didn't have to do this on this particular problem because they gave us the radius and slant height, which were the only 2 variables we needed. But let's say they gave us the height and not the slant height. Well, you should notice there is a right triangle created by the height, radius, and slant height. So anytime they give you 2 of them, you can find the third one by doing Pythagorean theorem. So there will be some of these problems where they won't give you these 2. They might give you the height and leave out the radius. Just do Pythagorean theorem to find what you need and then go from there. And the last one is a sphere. A sphere is the set of points in space that are a fixed distance from a given point called the center of the sphere. So, just like a circle, it's kind of like the same concept as a circle, but a circle is 2-dimensional and a sphere is 3-dimensional. So in a circle, every point on the circle is the same distance away from that point, that center point. Same thing for a sphere. You got a center point, but now we're in a 3-dimensional space, and every point on the surface of that figure is the same distance from that center point. Alright, for the sphere below, find the surface area, round to the nearest hundredth. So the formula is 4 pi r squared. So all you need is the radius. Well, the radius is 5. So we plug the radius in, plug 5 in for r, and we're just typing this in the calculator. 4 times pi times 5 squared. 314.159, and so on. If I'm rounding to the nearest hundredth, I'm keeping 2 numbers after the decimal point, so I look at the third number, and 9 is big enough to round up, so the last one I'm keeping needs to increase by 1. This was in centimeters, so any kind of area will be centimeters squared. Always units squared.